All right, now let's go a bit further using the key features of Legend Layer. Let's code a prediction market for a football game using web requests and calling LLMs in our methods. For that, we're going to do a search on this page of the BBC Sports and getting a match between two teams. In this case, let's try to resolve our prediction market for the game of Spain versus Italy in the UEFA European Championship, okay? Back in June of 2024. Okay, let's get into it. Let's start creating our new file. Football prediction market. And as always, let's start adding the first line that points to the GenVM version that we want to use. In this case, as always, we are going to import all the features of GenLayer, but also since this is a bit more complex example, let's import more stuff to handle our data and to having different and more complex types. Okay, now let's create our intelligent contract class. Let's wrap it properly. And let's create all the memory storage that our contract needs to have. Let's have a variable to store if the prediction has been resolved or not as a Boolean. Let's have the game date as a string. Let's have both teams, team 1 and team 2. All right. Let's have also the resolution URL as a string. Let's have the winner as an int. Right now in GenLayer, if you want to use an integer, you need to use the unsigned convention of U256 and also the score between them. Okay. Now let's define our constructor and all the values that we need to initialize our prediction market, which is going to be the game date as a string, team 1 as a string, and team 2 as a string. Okay, and let's initialize all its values. All right, let's start with the game date. Both teams. Okay, what else? We need to also initialize the winner, the score. Let's do a 0 for now. The score as an empty string. And also we need the resolution URL. In this case, that's going to use the same URL from the BBC Sports, adding the game date. This is going to take us to the specific page where we can see the score of this game. Okay, that's it for now. Let's add a quick method to read from the state and see if everything is going properly as expected. It's going to be our view method. Okay, and let's call it get resolution data. This is going to return a dictionary of the keys of the variables that we want to return and whatever type they may have. Here we can say we can have the winner, self the winner. We can also have, for example, the score, so self the score, and we can also have the has resolved flag. Okay, now we can see that there are no errors. Let's try to go and deploy our contract. Here in the construction parameters, we are going to be presented with a form that allows us to enter every parameter that we have in our constructor. Let's point to the date of the game and both of the teams. Let's hit deploy to see how it goes. The transaction of the deploying our contract is being executed, and we can follow that on the logs, seeing all its consensus steps. Okay, it seems like it's already finalized. Let's see on our read method if everything is as expected. Yeah, we see that the game hasn't resolved, there is no score, and the winner stays as we initialize that on our constructor. Now let's go the key method of our intelligent contract that is going to resolve this prediction market by requesting the content from the website and sending that content to our LLM just to see and validate who was the winner of this match. This is going to be a write method. And let's call it resolve. All right. This is not going to return anything. And here we need to craft our prompt. But first, let's validate if the contract if the prediction has been resolved or not. As resolved, we can return maybe a string, and we can change it here. All right. And now let's get the variables that we need to call and to use in our equivalence principle. Market resolution URL is going to be. This is important because inside the equivalence principle, since it is a non-deterministic block of code, we cannot access the storage of our contract. Okay, so that's why we need to create these variables outside of the equivalence principle block. One. All right. Now I'm going to declare the non-deterministic block. Let's call it non-det for now to be more simple and to understand better the concepts behind them. They can have any name, but for now, maybe it makes clear what it is, what we are using on our equivalence principle. Okay, this is going to return, in this case, a string, and we're going to see how. Okay, first thing that we're going to get is the web data. So let's use the GenLayer unique features to fetch that data from internet. gl.get web page, and we're going to pass here the market resolution URL. Also, we can request this data on HTML or text format. In this case, we're going to use just text. All right. Now, with your permission, I'm going to copy the prompt that I have already worked before because it's really crucial to get it right. And I'm going to explain to you how that works. Okay. So I'm calling this var task. And here I'm asking, right, to the LLM that in the following web page content, you're going to find a match between two teams. And I put the names of teams here and all the web data content that I fetched previously with genlayer.getWebPage. Now I try to give the LLM the rules to resolve this prediction market, asking that to get who's the winner and the score from the website and returning a JSON with the score and the winner team. Here I'm trying to put more helpers around the format of the response because I need to parse that properly in my Python code, and I don't want any other text that could break that, okay? So now, what we should do following, okay? So let's send this code, this prompt to the LLM, and let's see how it turns out, okay? So what we need to do, we need to Let me check my indentation. This is the same non-deterministic code. We're going to get here the result as genlayer dot exec prompt, and we're going to send the task here. Okay, and here we're going to do a little bit of formatting of our data. Let's do a replace of everything that looks like this for this one, and everything that could be closing that also, right? It's formatting with that one. Okay, now I probably can print my result and see on the logs. And also, as the final line on my non-deterministic code, I need to return the result that I want to be considered as the result of my equivalence principle. Okay, let's do a JSON.dumps. Let's do like a parse and encode and decode the parse and parse of the JSON so we can return as a proper dictionary. Of the result, right? Let's also ask for in our JSON dumps to sort the keys. All right. Now that we have our non-deterministic code, we're going to execute it with a function of our equivalence principle. So this is going to be a JSON.loads of genlayer.equivalence principle strict equivalence, and let's pass the non-deterministic function, right? So here, this strict equivalence of the equivalent principle is going to match the exact same answer. That means that whenever our validators process the same transaction than the leader, they are going to look for the exact same match between what the leader returns and what the validators returns. Okay, now we can do a little bit more of handling and data management just to save the proper values, right? So we get our result JSON winner, right? And if this is higher than -1, we can do proper change of our state. Has result is now true. Self.winner is the result JSON winner, and self.score is our result JSON.score. Finally, we can return the result JSON. That's it for now. Let's execute and try our code. Okay, let's now continue and try to test our intelligent contract. Since we added this method now, we need to redeploy it. Let's put the same date for now. Same things. And hit deploy. Now we can see on the logs how the transaction goes, executed. Let's go through the consensus steps. Now the leader has already executed and we're waiting for validators. They executed and now it's final. Let's call the get resolution data again just to be sure that everything stays as it should. All right, the game has not been resolved yet. There is no score and no winner. Now let's call the resolve method to see how it goes. Let's pay attention to the logs to see everything that goes. We send the transaction. Now delete